the calculus book, but uh-oh. Uh-oh. Somebody wrote down all the word problems in here. Uh-oh. Well, you know what that means. We're gonna do them. Plane radar. Okay, I'm gonna start off by saying that these answers are not gonna be the same on the test. Also, this answer is wrong, just so you know. It's not very wrong. It's just slightly wrong. I just didn't bother fixing it. It probably was a misinput in my calculator. I don't care. Anyway, what happened? Oh yes. Yeah, so these answers aren't the same on the test, but these problems, they're the same but with different numbers. And so I wrote down the ones that are on the test, and all of them are in the homework, by the way. And so we got plane radars, the first one. We're gonna do that one. So let's and also some of these other answers might be wrong too. I don't remember which ones are right and which ones are wrong, but I think some of them were slightly wrong because of misinputs in my calculator. Because I'm just awful at that apparently. Anyway, oh yeah, okay, this one. A plane flying horizontally at an altitude of 4 miles, 4 miles, and a speed of 465 miles per hour, passes directly over a radar station. Find the rate at which the distance from the plane to the station is increasing when it is 10 miles away from the station. So, how you do this is you got the plane, right? And the plane when it's over the station, you got this. This is the plane when it's over the station, and this is the station. If it focuses, then yeah. And then you draw a line, and that line represents the altitude at which the plane is flying, which is 4 miles. See, this is 4 miles. Now, the plane isn't, it doesn't spend very long on top of the radar. It's got places to be, so it kind of goes, it goes over here, and it yeah. What the fuck? Why? Okay, and then he's not done. Okay, hang on. It turns out my brother and his friend hate calculus, but so they're gonna be extremely loud. But yeah, who doesn't? So, yeah. So the plane, it was right here, but then it had places to be, so it went over here, and this is the plane's going. So this is basically represents how far the plane has flown, like horizontally, since it flew over the radar. So this is gonna be x. Now, you say, wow, there's 2 lines. It's almost as if you can draw this and it'd be a hypotenuse, and you'd be correct. So we're gonna do that. I might, hang on. Yeah, okay. There we go. It's kind of connected, Alright. And then we do this, that's a right angle. Okay. So this hypotenuse, it represents the distance between the radar and the plane. Because see, the plane's the plane's right here, and the radar's right here. So, this is the distance between them, because So this is going to be represented by y. Now, let's look at the problem. It wants us to find the rate at which the distance from the plane to the station is increasing. So, the distance from the plane's right here, and the station right here. So it wants the rate at which y is increasing. So that's going to be dy over dt, because basically the reason why it's dy over dt is because y is the distance. So the rate at which it's increasing, derivatives are rates, so the derivative would be the rate at which the distance is increasing. But it's dy over dt instead of dy over dx because it's relative to time, because it's speed. So So we're looking for this when it is 10 miles away from the station. So when y equals 10. So when y equals 10. So we're looking for dy over dt when y equals 10. Now, for x, it says that the plane is flying at a speed of 465 miles per hour. So, go back over here. The plane goes from here to here. So basically, the plane's speed is going to be basically the rate at... Oh my god, fool. Hang on. Alright. It's going to be the rate at which x increases. So, that's going to be dx over dt. And it gives us the number 465 miles per hour. So we know dx over dt is 465 miles per hour. So that's the rate. So that's the rate at which x increases, and we're looking for the rate at which y increases. So, how can we do this? Well, we have a right triangle. So, we set up an equation that includes both x and y. So, y squared equals x squared plus 16. And that's 16 because 4 squared is 16. So, now we just find the derivative relative to time, which is basically like finding the derivative, but it's like adding an extra step to chain rule. So take the derivative of y, for example. So we're gonna do the derivative of y relative to time. If the camera focuses, please. Thank you. Okay. So you have the derivative of y. You start by taking the derivative of y, which is just 2y, or derivative of y squared, I should say. It's 2y. And then you add, then you just add dy over dt next to it. You multiply the derivative of this by dy over dt. And that's basically how you can take the derivative of y relative to time, despite the fact that time is nowhere actually in the Pythagorean theorem equation. So, now we do it on the other side. We have 2x, and that's going to be plus 0. So 2x plus 0, which we're not going to put because that would just make it more confusing. 2x times dx over dt. Okay, so now we're looking for dy over dt. That's going to be our answer. So we have to solve for dy over dt. Now, how can we do that when there are other variables? So what you got to do is you got to plug in the variables that we have. So far we have dx over dt equals 465 miles per hour. So we know we can plug in 465 into dx over dt. But we don't have x or y. So the way you find x and y is, well, actually we do have y. It's y equals 10. It gives us y equals 10. We have to find x. Okay. The way you find x is you set up with the equation y squared equals x squared plus 16. And then you plug in the 10. So 10 squared equals x squared plus 16. And now you can just solve for x. So this is going to be 100 equals x squared plus 16. And then that's going to be x equals the square root of 84. Because you minus 16 on that side, and that's going to be 84, and you do square root. So we have y equals 10 dx over dt equals 465, and x equals the square root of 84. So we can plug all of those into this equation so that we can solve for this. Also, so let's continue solving this. So we can cancel out the 2's here because you're multiplying by 2 on both sides, so they're just going to cancel each other out. And then we can plug in our y, which is 10 times dy over dt equals, and then we plug in our x, which is the square root of 84, and we plug in our dx over dt, which is 465 times 465, and then basically you just divide by 10, so then dy over dt equals 465 times the square root of 84 all over 10, and then I'll plug it into the calculator. Yeah, alright. So, okay. 84 square root times 465. Okay. 465 divided by 10. And that is 426.18. Or 426.2, basically. Yeah. Yeah, okay, because you round, I think you round to the nearest. I don't even think it says what to round to. Okay, you round whatever it tells you to round to, but this is you're gonna be your answer. So now we have dy over dt equals 426.2 miles per hour. And that is our answer, 426.2 miles per hour. Don't forget about the miles per hour. So that's how you do the plane radar question. I'm going to be doing all of these. So it's going to be a lot of time, I guess, but it's okay. Alright. If you have any questions about this problem, like if you're still confused about it, or if like there's something that I could clear up, don't be afraid to let me know. I mean, these are all on the test. These are the ones that you need to know to get 3.9 questions right. Like you don't, if you have spent so long not understanding, like even if like you were to play this video over and over again, you think you still wouldn't understand. At the very least, I would recommend trying to memorize how to do this, because these aren't going to be the same answers. Some of them will be the same answers. I don't remember which ones, but all of them are the same procedure as the ones on the homework, and I wrote down which ones are on the test. It's just most of them don't use the same numbers, so I wouldn't recommend copying the answers. I would recommend copying the procedure. I would recommend learning this, because honestly, I think I can help you if you want help, but that's okay if you don't. Okay, that's all. I will be moving on to, I don't even know which one's next. The one that's next in my list that I wrote down in my notes that you saw. Okay, bye.